Hello, this is Phil Vaca here again with Enterprise DB, continuing our series on building production-ready containers. We'll be exploring volume management and replication with Postgres+. Many people who are new to Docker find themselves asking a simple question: what do we do with our data when our data is important enough that we need to keep it? The basic idea of Docker is that every image we build is stateless. Images are not like virtual machines. We don't want to restart them. Instead, we kill the image and start a new one. In situations like this, what can we do with our data to make sure that the data stays available outside of the container's lifecycle? The answer comes in a technique called volumes. Volumes are described in the Docker file or externally from the Docker run command and are used to ensure that specific host storage is mapped to a Docker container. Let's take a look at an example, and I think you'll see what I mean. For the purposes of this demonstration, I'll be running inside the Docker virtual machine to better simulate what it would be like in your production environment. For all databases, and certainly for PostgreSQL, it's important to manage storage. It's a common database management technique to separate write-intensive loads from read-intensive ones on separate partitions that map to separate drive structures. For example, one might separately mount the PG data directory, the Postgres write-ahead logs stored in pgxlog, and the Postgres running logs or operating logs stored in pglog, and put those on separate mounted file partitions. The first thing I'll do is create some directories in the local Docker host that represent the database storage we want. Then I'll start a Docker image whose only purpose is to map these volumes. The Docker image that's bound to these folders doesn't even need to be running. In a volume-only scenario, one container starts that maps the volumes, and other containers will link to this. We see that the image exits immediately, but the storage will still be available. Next, I'll start the Docker image that will actually host Postgres+ Advanced Server and listen on port 5432. Here's the important part. When I run the image, I specify that the volumes are from our volume image. In all other regards, I start the container normally. When I run Docker PS, I see that only one image is actually running, the Postgres container. If I exit my virtual machine, now I'm on my local machine where I have the pSQL tools installed, representing some remote host. And we can easily connect to the remote Postgres image. Now if we connect back to the host, we'll see that the storage is exactly where we expect it to be, mounted externally. Running the containers in this way allows us to stack multiple containers on top of each other. One to manage the volumes, one to run the Postgres+ server, and as we continue to add new features, like Enterprise DB's failover manager, these too will exist in their own stacked and linked containers. One thing that's important to note about volumes defined on the command line is that even when the containers referencing them are removed, with -f for force and -v for volume, the data mapped to the host persists. Now we see nothing running. However, the Postgres files themselves are still there. We can also use linked containers to quickly and easily set up replication with Postgres+. Let's show a fully replicated Postgres environment. I'm going to get rid of these temporary files now so we can set up a scenario with full replication. I've created a script that'll automate this process for us and show you how two containers can be linked together as a primary and a replica. First of all, the script defines some directories for pgdata, pgxlog, and pglog, and creates those directories if they don't exist. If there are some artifacts from a previous run, it'll delete those. Now it does the same thing again for our second container. And we create two volume-only containers, one that'll be our master and one that'll be our replica. The names of these don't matter, and in fact it would be bad practice to call one primary and one replica, because in a recovery scenario, their roles could easily change. Next, we start the image that'll be our primary. making sure to specify volumes from the appropriate machine. Then we start our replica. Now you may notice two command line switches that we haven't seen before. The first, -IT, specifies that we'd like an interactive terminal that responds to keyboard commands. Next, I add the link flag to show that this container will be linked to its primary. This means that the name will be resolvable because an entry will be added to the hosts file that stays up to date with the internal Docker IP addresses. This simplifies network management for us greatly and is a very helpful switch. For the purposes of the demonstration, I'll start that last container, add a bash shell, so I can show you the entry point script running. Now I'm present in a bash shell in the container that will be our replica. Now we mentioned that the host alpha would be resolvable to us, and we can verify this. Ordinarily, when the Postgres Plus container is started, it runs the entry point script, and this script accepts a few different command line options. If we start the entry point script specifying the command line options replica and the name of the machine that's the primary, in this case alpha, replication should start almost immediately. With the Postgres process running, we simply detach from the machine to verify that we now have two working Postgres Plus images. And here we see our master and replica running on ports 5432 and 5434. Let's again exit the host to use our PSQL command line and verify that the containers are in fact running and replicating. And we can verify that the replica immediately has the data. With this demonstration, I hope you're beginning to see the power that containers offer. Here, we set up a fully functioning, replicated environment using multiple Docker containers in a matter of seconds. These containers are provisioned in such a way that we'll be able to easily manage storage, and we begin to see how they could find a home in a production environment. Please join me for future presentations as Enterprise DB continues to show you how you can build a production-ready environment using Postgres Plus Advanced Server in Docker. Thank you.